Welcome, Algebra, to your very first screencast, and the topic that we're going to start with are true and false equations. And we start with that because it kind of helps you get to know your calculator a little bit. If you were in boot camp, you did a little bit of this, so you're pretty good expert at it. But you might not have taken notes the way I wanted you to take notes. So we're going to do some Cornell notes on this. I've already explained that to you in class. And the idea behind true and false equations is that your calculator, while it can't show you the steps on how to solve an equation, it can tell you if the left side is actually equal to the right side. So it doesn't like variables, and if you do try to put a variable in, a lot of times people put in a letter, but a letter has a stored value. We'll get into all that in a minute. It'll say something like, maybe like a little kid will come up to you and say, hey, 1 equals 10. I don't know, maybe they're trying to make a joke and you don't get it. Neither do I. We know that 1 doesn't equal 10. That's not a mystery. We don't need a calculator, but you can try it on the calculator, and what will happen is it'll just pop out saying 0. And when the calculator says 0 for an answer, when you have an equal sign in the question, we'll call it, that means false. So there's nothing to solve there because there's no variable. So that's why when the 0 pops out, that's what it means is false. Why don't they just write false? Because the calculator can make letters? I don't know. Doesn't that seem easier? Seems like it should just say false. But it'll say 0 and that means false. True would be 1. So if you write 3 times, it'll be like an asterisk, 3 star 3, 3 times 3 equals 9, we know that that's true. We don't need a calculator, but we can test it on the calculator. It'll pop out 1. And what a 1 means is true. So 0 is false, 1 is true. There's not much more to say about this. There's a lot that we're going to do in class to make sure you input things correctly into this new calculator. Some of you have used for the first time. Some of you may have bought it over the summer and have no idea what you're doing with it. We'll get a lot of practice in class, and you can tool around with it at home. But essentially, that's what it is. And I'm actually going to show you on the calculator. I have a little computer program that I can use so we can see what it looks like and put some more complicated things in. Alright, here it is. I also figured out something there that it automatically pauses when I tried to switch it the way I switched it, so that's good to know. So if there's a weird audio thing, that was why. So here's the calculator. Just so you know, see how the clear button is red? That it shows up red whenever I hit it, so it's easy for you to follow what I've pushed. But I just want to show you something that I had already typed. So we did 3 times 3 already, and we said that equals. Now the equal sign, it's nowhere on the front of your calculator. What you have to do is go to this test button. I don't want to hit it yet, but the third one down on the left is called test. And actually I think I can draw right on it, but I'm not going to right now. So you have to hit second and then the math button, and it brings up some useful symbols that you're familiar with: equal, not equal, less than, greater than, all those. So we want the very first one. You can either hit 1 or hit enter when it's on 1, and it shows the equal sign. And we're going to put in 9, and we're going to hit enter. And we got an announcement here. Oh, look good, there's going to be a fire alarm. So I'll have to hopefully be done by then. So you see it says 1, and that's what we wanted. We want 1 because 1 meant true. Now if I did 3 times 3, oops, didn't do it, times 3 equals, so test, I wish there was an easier way to get the equal sign, equals 8, which we know is not true. It doesn't even matter if it's close. If it's not exact, it will pop out a 0, which is false. So chances are, if you just type in random things, 856 minus 81 divided by 9 plus 3, and then you put an equal sign. Oh, let's see. And I just randomly put 64. I bet that I am wrong. It's true, I am wrong. So 856 minus 81 divided by 9 plus 3 equals 64 is not true. You might be thinking, that's not very useful. I figured it wasn't true. But when you are working on your own problems and you want to check your work, you want to do all these different things, it is very useful for this. Now let's say you have like a giant number that you didn't want to enter in constantly. What you could do is take a number, let's say it was 9 million, and you just didn't really want to type those zeros every time. There's 9 million. You can store it into any letter on the calculator. So there's a button for store. It says STO, means store. And it shows a little arrow. It's like putting the 9 million into something. And then you can literally pick any letter in the alphabet. I'm going to pick C just for fun. So I'm going to hit alpha and then the green C button. And I hit enter. And it just repeats it. So now whenever I hit C, it'll say it's 9 million. If I were to put C plus 2, I would expect it to be 9 million 2. And it is. So it's a really cool way of, if you have this large number that you're working with over and over again, like maybe you're doing testing if you're a scientist, you could just say C instead of 9 million, especially if it was 9 bazillion with lots of other numbers in between. Bazillion, by the way, is not a real number. So you could do tests like that. You could say, oh, how about 6 million plus 3 million, which hopefully I have right is 9 million. Oop, I need another 0 there. Oh, I need another 0 on the other one too. Insert another 0. Okay, I'm going to get back to the end. There's a little tutorial on how to fix a mistake you made. Your calculator is actually a lot faster than this computer calculator. So I'm going to say equals test, enter, equals C. I'm going to put 9 million this time. I'm going to put C and see if it still makes sense. It's true. So the calculator remembered that 9 million is C this whole time, and it'll remember forever until you reset your calculator or someone stores something else in C. So that's at least 26 values you can have stored at once, as long as you remember what you stored in which letter. Alright, so hopefully that'll help. We'll do a lot of more practice in class when you come back. So finish those Cornell notes, maybe write some question, maybe you have a question that I didn't answer, and we'll see you tomorrow. Or the next day.